Good afternoon, everyone. In the today's session of robotics class, I would like to discuss the types of rotary actuators. Presently, we're in the talk of different types of actuators that are being required for the commencement of the work by the robotic links and joints with the different segment orientations. As in the sliding aspects, nothing but the prismatic movements in the coordinate system, or in the rotary type of connectivities or revolutionary type of basis of works. Before moving on to that, I would like to challenge the difference between those hydraulic and pneumatic systems. As with respect to the circuit diagrammatical basis, we had a detailed look in the previous class, and we'll just recall the small concepts related to the hydraulics and pneumatics, the basic differences in its aspects of working, in which it plays a major role for the mode of working of the actuators. So hydraulic based of working actuators, pneumatic based of working actuators. Coming to this hydraulic system. In the hydraulic system, the pressurizer liquids plays a major important role for the driving factors. Nominally, in the case of this pneumatic systems, it employs or will be utilizing the compressed gases or air which is abundantly available within the environment, plays a major role for driving the actuators. Normally, in the hydraulic system, the system operates at a maximum pressure of 700 bar of pressures. In the case of this pneumatic, it will be limiting to some extent. That too operates at 5 to 10 bar of the pressure, but not a greater than that of 10 bar. Generally, in the hydraulic system, we'll be utilizing the closed system, as it gives the feedback alignments towards the system. And its working scenario to how far the given set of instructions in the base of the program has came into the existence in the working environment. In the case of this pneumatic system, normally you will be utilizing this as an open loop type of control system. Which is particularly doesn't have much opinion regarding the feedback alignments. In the case of these hydraulic systems, a mini leakages will be getting occurred, and that affects the system working environment within the hydraulic conditions. Nominally, in the case of these pneumatic systems, even the leakages doesn't affect the system environment in the case of its working mode. Even the valve operations are very much difficult in the case of this hydraulic system, as the functionality will be very much high end in nature. In the case of this pneumatic region, the valve operations are very much easy. Comparing in weight concept, hydraulic, normally the fluids, The occupational volume of space will be getting deferred, but the weight conditions is similar in almost all with respect to the solid effects and with respect to the liquid effects. Whereas this in the new pneumatic conditions, of pressurized air, automatically gases tends to move away from the gravitational sections because of its less density, very much less density. Hence, the hydraulic system will be having very much high in weight factor based on its components and system of work, and pneumatics, it's light in weight. The pumps are used to provide the pressurized liquids in the case of hydraulic system, and in the case of this pneumatic systems, compressors are used in order to impart the pressure and store the gases with pressurized conditions. Hydraulic will be having a rate of firing and it leads to an hazardous environments, whereas this pneumatic system is very much free and very much less in hazardous situations because only the normal atmospheric air will be utilized, but a noisy with respect to the operations will be considered and quick actions will be taking place in the case of this pneumatic systems. The only major difference is in the case of this hydraulic system, it can call as a self-lubricant controlling device because fluids itself acts as a lubrication for the entire system. No additional lubrication is necessary for the components which are working in the case of this hydraulic system. Whereas in the case of this pneumatic system, a special arrangements are required for lubricating. Hence, a unit called FRL unit, so filtration, regulation, and lubrication device will be placed in the case of this pneumatic system for the filtration sector and utilizing the system environment for commencement of the activities by the actuators. Coming to the rotary actuators, hydraulics and pneumatics. So we're having different types of rotary actuators which are operated by both these hydraulics and pneumatics basis. The first one is the gear motor, a vane motor, piston motor, turbine motors, and some generator type of motors. In order to impart the controlling strategies, we will be utilizing the different valves to safeguard the entire system in a particular strategy. Nothing but holding of the objects to a particular range for safe mode of operations. So for that, we need to transfer the fluids or else the gaseous which are in the pressurized conditions from the inlet region to the outlet region, nothing but into the actuators for getting the work to be done. We'll be utilizing different kinds of valves. So for giving the perfect directions for activity commencement, we'll be utilizing this directional control valves for the better control of operations. Secondly, the pressure control valves, so limiting of the pressure or else regulating, increasing of the pressure. Thirdly, the process control valves. So safest mode of operating of the entire processes. Coming to the control valves, the fluid power which is imparted by the motors are controlled by these particular valves and made to travel or direct this hydraulic generated power, which is generated by the fluid functions, or is the pneumatic power, which is generated by the compressed air or this gaseous in particular directions as per the specified strategies, or we will be calling as some route maps, guiding route maps. So for that particular agitations, by regulating and transferring either of the effluents, that is hydraulic fluids or else this pneumatic gaseous mediums, in both these systems will be utilizing commonly these three types of valves for safest mode of operations and to energize the actuators for the prescribed task to be done or work to be commenced. And the directional control valves plays a basic role for giving the particular direction or way, path, or route map of the fluids to be flown for the end commencement of the task. Secondly, the pressure control valves. In order to increase the pressure as per the work requirement, whenever it is necessary, and decreasing the pressure for the safest mode of operations if the beyond limitations pressure has been increasing. And entire the process control, that is the safest mode of operations. So the required maintenance of the pressure and DCVs are placed in an appropriate conditions for a better mode of operating the valves. Let's have a detailed look of this valves. Coming to the flow control valves. Normally, flow control valves are used to limit the speed of hydraulic actuators, or used to control the valves, the fluid speed. Nominally at the discharge conditions. So discharge is nothing but the outlet range of the conditions. Nominally, we'll be utilizing this needle type of valves and gate valves and even the globe valves, which used to observe in our domestical way also, domestical purpose also will be utilized. Ball valves, globe valves. Coming to the classifications or the major key points of this needle valves, mostly utilizing this needle valves as an flow maintenance valves, or else in order to restrict the discharge and discharge flow or quantity of the fluid at the discharge point of view. Nominally, the valve is made up of with a needle or a pointed threaded stem that will be having an adjustable range that use it to monitor manually the flow of the fluid. Nominally, you will be utilizing steel material for manufacturing of this threaded stem and its controlling agitations. Even this valve also can be used as a stop valve in order to prevent the flow of the fluid from one part of the hydraulic system to the another part of the hydraulic system. So it acts as a bridge, and whenever it has been unlocked, then only the fluid of offense will be moving from one side to the other side whenever it is allowed. This is the pictorial representation plays a major role as a needle valve. So upon clockwise turning, the threading conditions will be getting locked, and the diameter of the passage which is allowing to flow the fluid will be getting obstructed by this needle. Whenever it is again rotated in counterclockwise direction, obviously it will be getting lifted towards the upward direction, and the fluid will be allowed to flow from the input to the output region. Coming to the globe valve. And this valve will be obtaining a huge area of flow nominally which is greater than the needle valve. Hence, we can clearly observe that the discharge capacity or flow rate, even at the low pressure drops, also will be very much great in the globe walls when compared to the needle walls, or nominally will be in an equivalent strategy. Probably it will be incremental in range when compared to the needle walls. Is to observe is global walls will be having a round disc in order to control or stop the fluid flow. In the case of this needle valve, we have observed just here by throttling, the area will be getting narrowed and entire the passes will be getting closed. In such a way, the obstruction is taking a place. But here, in the case of this globe walls, it doesn't have that much of flexibility. Only the orientations also will be very much less in manage, less in range. See, this globe walls automatically will be having a less threading region. That too will be of only one orientational sector, or else the maximum of two 360 degrees orientations, but not a much more with respect to the needle kind of walls. It will be, and upon locking, the flow passage will be getting obstructed, and upon opening, entire the flow rate will be getting connected for a better passage as displayed in the diagram very much clearly. So what basic difference it is that high discharge conditions will be getting taken place because the area will be very much increasing in strategy when compared to the throttle valve, sorry, the needle valve, which is placing a major role in the case of this throttling. But here in the globe valve, there will not be having much throttling aspect. Will be limiting to 2 to 3 threads, and which will be having nominally 180 degrees or entire in its 360 orientations, most probably 3 to 4 360s, nothing more than that 4 rotations. Coming to the gate valve, normally these gate valves are utilized as flow control valves. Casually, you will be calling this as a non-written valves also. Gate valves are also called as the non-written valves. Hence, we will be calling this as an check valves also. non-return valves, check valves, gate valves. Most probably, these gate valves plays a major role in order to stop or to open the line of flow. Hence, for processing the full flow, that too not in a decremental of its flow rate. Minimally, in the case of these gate valves, the startup can be done with a minimum pressure drop and the flow can be continued with the greatest discharge capabilities. Hence, this gate valves plays a major role that it provides a high discharge rate with a minimum pressure drops also. See here, the picture real representation plays a major role that when physically it will be getting observed in the case of our just like as some our dam gates. So slowly it can be increased, or else the pressure will be getting decreased slowly if the counterclockwise rotations has been taken place, and gate will be getting just raised towards upward, and pressure will be getting dropped to some extent, and greater discharge will be getting taken place. And upon complete opening in condition, the flow rate will be in nominal range. But if the restriction has been taken place, it will be increasing in its the pressure where the velocity of the fluid at the discharge rate will be getting increased. But quantity, that is nothing but the volume of the fluid will be getting decreased. Coming to the pressure control valves. Nominally, these are used to regulate the pressure. So control is nothing but in order to increase the pressure or else to decrease the pressure or maintaining the constant range of pressures. In the system orientation, either in the open loop control system or else the closed loop control system, and different positions as per the requirements. For loading strategy in the sense, automatically the pressure conditions need to be increased. And for unloading conditions, the pressure strategy should be decreased. As per the safe mode of application or safe mode of operations, maximum pressure should be limited at a safe mode of operation. So the pressure has been increased than the resistible operating pressures, the system failure leads to taking place. For reducing those kind of situations to be taken, the pressure control valves plays a major role. And even this can happen for getting the better access by the virtue of pressure control systems. So how many classifications or else the types of pressure valves or relief valves, pressure valves are getting existing? It has been listed with 5 different types of pressure valves. First one is the pressure relief valves, releasing of the excess pressure that is being generated during the operational conditions. Pressure sequencing valve, allowing the pressure whenever the required pressure has been achieved, then only the required pressure will be getting sucked, and by maintaining the constant pressure, then it is allowing for the system operation. The second condition. Third one is the pressure reducing or regulating valve. In order to increasing or decreasing strategy, this type of valve will be utilizing. Pressure unloading valve. So unloading valve in the sense excess pressure which has been existing Even after the completion of the task at the end position. Pressure brake valve, nothing but for cutting off the pressure for transferring than the additional range that has been taken in the system commencement or in the system operations. Individually, we will be looking after the one by one. Pressure relief valves. Normally, we use it to find this pressure relief valves and mostly both in hydraulic way of operating systems and the pneumatic ways of operating systems. Normally, these valves will be in closed conditions and will be having a common connection with respect to the system line, systemic line. By that, we can ensure that the set pressure is being maintaining within the system or not. That is the first indication. And if at all additional pressure is being entering into the system, automatically the set limitations will give the signal to the control system, and the control system will energize this pressure valve, and excess pressure will be drained to the oil reservoir back again in the case of hydraulic system, and excess pneumatic pressure will be getting released to the atmospheric range in the case of this pressure relief valves. So normally we used to refer the diagrammatical source here, entering the source pressure. So safest mode of operations will be entering into the nominal zone, and if at all additional is being entering, will be moving on to the tank zones, and excess pressure it will be released into the back to the oil tank. See the symbolic representation here. Initially, the connectivity will be like this. Maintaining of the system pressure will energize the compression existence within the sequence when up to the sequence has been taken into the place. So hence this poppet valve will be raised towards upward direction by maintaining the perfect pressure, and later on will be given a passes to the tank in multi directions towards the left or towards the right as per the T shape of connectivities, and passes will be getting taken place. So the excess pressure has been taking place, then automatically it will be releasing, then it will be cutting off the pressure limitations. And after getting the enough pressure for operational sector, then only the valve will be getting energizes. That is the condition of this pressure relief valve. And coming to this pressure sequencing valve, finally the sequencing valve is used to direct the flow to more than one portion of the fluid circuit, that too in a sequential mode. See here, see pressure sequence valve will be having a connectivity. There's the inlet pressure, and will be having connected towards the outlet pressure in the initial conditions will be having closed with respect to the second port, and simultaneously by closing this first port, second port can be energized like this. Second port will be closed by the DCV, and the first flow will be getting taken place. And here the fluid which is entering by will be getting stopped by this piston and will not be leading to enter into the second port, and only the entire fluid that is being entering here will be delivered with respect to this port number 1 only. And in the second position, if you have been seen, simultaneously the end piston is not allowing to flow any type kind of inlet entering fluid to flow in the port number 1, and hence entire the fluid will be flowing to the port number 2. As the sequence will be some is an important role for operating or guiding multi flow valves simultaneously. Next one, the pressure reducing valves. These are normally open pressure control valves that are used in order to maintain the reduced pressures, particularly in a hydraulic systems at certain positions, not in almost all the regions, in a certain positions. Basically, these are actuated by the pressure sensed in the branch circuit and are tend to close as it reaches the pressure of the wall. There is setting preventing further buildup of the pressure. Nothing but not increasing than the moderate energizing range of pressures. So normally it used to set a particular pressure for safe mode of operations and will not allow the much pressure than the safe mode of operating pressures. And if at all it is being maintained, automatically it will be reducing and discarding the build-up pressures. As the pictorial representations, as this allows the adjustment when it has been released, automatically the pressure will be high pressure will be getting limited to its and adjustable medium will reduce the pressures at the drain conditions. These are the different modes of valves which are utilized in both this hydraulic as well as pneumatic conditions of the systems which are operating to energize the rotary type of actuators with an efficient range of pressures. Thank you. We'll be meeting in the next class.